Functions and their properties. First of all, what do we mean by a relation? A relation is a set of ordered pairs, and the set of all first components is the domain, and the set of second components is the range. So in this graph, we have the relation between people and their income. So we can write this as a relation. Now, the set of the first components is the domain, and the set of the second components is the range. So a relation is a set of any ordered pairs. Now here we have an example and we need to find the domain. So the domain is as such, and the range is the set of the second components. Now a function is a corresponding from a first set such that each element in the domain corresponds to exactly one element in the range. So if we look at the examples we have, let's look at the one that is not a function, and y is not a function because 3 is related to 2 elements and 11 is not related. This one also is not a function because of the 6 is related to 2 elements, while this one is a function. So let's see the example and let's determine which relation is a function. So the first one is a function, we don't have any issues. Now the second one is not a function because 6 is related to 1 and 2, and the third one is not a function because 5 related to 6 and 8. Now if we have an equation, we need to solve for y, and if y has more than one expression, it means y is not a function of x, and keep in mind x is the independent variable and y is the dependent variable. So in this example, we need to determine whether each equation define y as a function of x. So first, we need to solve for y. So the first one, y equal 4 minus x squared, one expression for y, so that's a function. The second one, we got y equal plus or minus square root of 4 minus x squared. After solving for y, we got two expressions for y, so that's not a function. The third example, y equals 6 minus 2x, that's a function. And the last one expression for y, so that's a function. Now we need to evaluate a function. Keep in mind the function notation f of x. So we have f of x equal negative x squared plus 4x plus 1. If I want to evaluate f of 3, just replace x by 3. The same example, if I want to evaluate f of t, just replace x for t. Now again, the same example, if I want to evaluate f of x plus 2, just replace x for x plus 2. So don't forget to FOIL and distribute. Then we need to simplify. Therefore, the final answer is negative x squared plus 5. Now, if I have a graph, I can tell whether this graph is a function or not using the vertical line test. What does the vertical line test say? It's a vertical line, and if it intersects my graph at more than one point, so if the line intersects my graph at more than one point, it means the graph given is not a function. So if we look at the first example, we draw a vertical line and it intersects my graph at one point, so that's a function. The second one, the vertical line intersects at 3 points, that's not a function, and so on. So if the vertical line intersects my graph at more than one point, it means the graph given is not a function. Now let's see examples related to functions. So we have this function here, and we need to find f of 2. So it means when x equals 2, what is y? When x equals 2, what is y? So from 2, we're going to draw a line, and when it hits my graph, we're going to read the corresponding y value, and in our case here it's -4. Now f of -2 is also the same -4. F of 0 is 4, and f of -5 is 0. Now, we call this point the y-intercept, and we call this point the x-intercept. And notice how the x-intercept doesn't have any y-coordinate, and the y-intercept doesn't have any x-coordinate. Or in other words, the y and x coordinates are 0. Now the domain is the set of x values where my function is defined, and the range is the set of y values where my function is defined. So the domain is the set of x values, or the interval of x values where my function is defined, and the range is the interval of the y values where my function is defined. So if I look at this example, the domain is -infinity to +infinity, while the range is -infinity to 4. Now the x-intercepts, we have them as -3, 0, and 1, 0. The y-intercept is 0, 3. Now f of -2 is 3. Another example, the domain is -infinity to +infinity. The range is from -infinity to -4. X-intercept none. Y-intercept is 0, -4. F of 1 is -5, and f of -5 is -9. Another example, the function domain is from 0, close as 0, to +infinity. The range is from 1 to +infinity. X-intercepts, we don't have any x-intercepts. Y-intercepts is 0, 1. F of 16 is 5, and f of 4 is 3. Functions domain is close at 0, open at 3. Function's range is from -1 to 8. Keep in mind, because we have an empty circle, so it's open interval. X-intercepts 1, 0. Y-intercept 0, -1, and f of 2 is 3.